How's it going, everyone? Welcome. My name is Nate Allen, and I'd like to encourage you all to watch these videos in their entirety. I'm going to start you off with this first one, which in trigonometry, the geometry of triangles, we need to start with simply defining angles and all the parts that go with them. So we're going to start off slow here and go right into angles. So within these notes, I'll have some definitions and things to try to help you to supplement your reading or watching of other videos. So feel free to take notes on this or just follow along as quickly or slowly as possible, or whatever you need. And then watch and work through some of the examples that I've worked through with you. And then hopefully also you guys will then be prepared to practice on your own and do really well with the content. And remember, you can always do more, but whatever I assign, that should be the bare minimum that you do. Okay. So we're just going to lay the foundation of trig by talking about the attributes of angles. And so we're starting with, in particular, lines, segments, and even these things called rays. And each one of those requires 2 points. One, the line goes through both points indefinitely. Segment starts and ends at those points, and a ray starts at one and goes through the other. And so what we're going to focus on in this section is a ray and one initial point called the vertex. And because we first originated with an x and a y axis, then that's what we will start with is at the origin, which we will call our vertex, and we will start by facing the positive right direction, aka the x-axis. All right. We will then take that thing and rotate it however many degrees, we will define that in a minute, we would like to create what is called an angle. Now notice it is called an initial and terminal side. Not a big deal, but if the book references it, I want you guys to know the initial side is where we started, and then we rotated or terminated that ray by moving it some angle to get that other side we're calling the terminal side, where it ends, terminates. Okay, so a bunch of different parts. Notice we did start in the positive x direction and we rotated in the positive y direction. And you can probably guess why we want to start off this class, excuse me, the angle positively. So make sure that you guys understand the difference between a positive and negative angle. Okay, and again, we're going to go over all the different types. So hang in there. I know some of this you probably have seen in geometry throughout high school or previous math courses. So just try to give you a little bit extra, something new, such as where angles in the measurement that we use called a degree was actually created. The Babylonian people were very interested in the stars, these things that would appear in the night when the sun went down. And what they actually believed over 4,000 years ago was that after mapping it out and trying to see the stars and how things changed, that it would make one full circle. Now, they thought that the sun revolved around the earth, right? We are the center of the earth. And they came up with 360 days for that one cycle to come around. Pretty amazing. A lot of people argue the fact that it was just that. It also could have been that they believed that 360 was a really good number because there are a lot of divisors and so on and so forth. But if you're more interested in the history, check it out. But we're going to start by talking about what a positive angle means. And that means we're just going upwards from our initial x-axis, or negatively means we're going to start downwards. All right. So that's how we define positive angles versus negative angles, so that we know if we're going to rotate, say, 40 degrees, do we go up 40 degrees or do we go down 40 degrees? All right. Pretty straightforward. Some of the other types of angles we'll talk about are what are called acute angles. Those are those little acute ones that are between 0 and 90. We stop at 90 and call that a right angle, which many of you guys are probably familiar with. And to denote an angle, we actually use a Greek letter. It is theta. Looks kind of like a 0 with the line through the middle of it. Okay, this is what is called theta, and that's what we usually use the symbol in order to represent an angle, typically in degrees. Okay, so once we get to that 90 degrees, if we kept going, we would get what is called an obtuse angle. And if we kept going even further, then we would get to 180 degrees, and that is what is called a straight angle. Okay, so those are the types of angles that we're going to deal with. And you may be asking yourself, well, I know if I go all the way around, that gives me a full circle, and that's that 360 degrees you referenced that the Babylonian people came up with. Well, you're absolutely right. So why do we not have names for angles that are greater than 180? Well, if you think about the drawing of these things, right? And if I was to actually start rotating around, well, if I tell you to go more than 180, say 200 degrees, well, then rather than going 200 degrees, which is going to make me go all the way here plus 20 more just to get to that point, what could I have done instead? Instead of going positive 200 degrees, I could have gone negatively to get to that same point. How much? Remember, if this was 180 here, then I'm going to come back that extra 20. So that would be negative 160 degrees. So it would be a lot faster to get there rather than going 200 degrees to just go 160 in the downwards direction rather than the positive upwards. So that's why we usually don't talk about any other names other than the acute, between 0 and 90, the right, exactly 90, obtuse, which is greater than 90 but less than 180, and that straight angle, half of a circle of 180 degrees. We can actually get even more precise with angles and talk about, instead of just decimals, which we know we can have, say, 23.5 degrees, what if I wanted to get that to be even closer than just 0.5 to the nearest tenth or even the nearest hundredth? Well, what we ended up doing was breaking these things up into what are called minutes and seconds. And you guys are already familiar with these terms, and you're already familiar with their breakdown, their makeup. You know that 60 seconds makes 1 minute, and that 60 minutes makes up 1 hour. Now, the only thing that we're going to change is, instead of 60 minutes making up an hour, that is what is going to make up our 1 degree. So even though we could take this full circle here and we could cut it into 360 little slices, which each one of those would be 1 degree, we can then take each one of those degrees, those tiny little slivers, 360 of them, take any one of those and we can cut that into 60 parts. And each one of those would be what is called a minute. Now, very small, we're getting very exact, but we can even take one of those minutes and cut it into 60 parts, which again would be what is called a second. Okay, so we won't use this very often, but the notation that we will see is right here. That is what is called a minute, and that is what makes up a second. Okay, so the cool thing is you already are familiar with these. I know it's new terminology. You may have even seen these in movies, like war movies, where there's a sniper. They would click the little top, and that just a smidge, they would just move it just a little bit, not a whole degree, but just a minute or a second to try to get the right target. Okay, and some of the other ones that we'll get into are called quadrantal angles. And you can probably guess that those come from our X and Y axis, which makes up 4 different quadrants. And this one would be what is called quadrant 1, because that's where it's positive, positive. And then they switch the X first to be negative, keeping this positive. So we went here to the left 2, and then they changed the Y value next to be negative. So that is quadrant 3, and they use Roman numerals for these as well. And then quadrant 4, 1b4, 5 there, would be where we are then positive and still negative. And again, that is why we start from the origin facing the x positive direction, and we rotate it around what we call counterclockwise because of the quadrants and the positives and the negatives and the way that they decided to build these. So what quadrantal angles are angles that lie on one of our 4 quadrants. So if you were to pick a point here, 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 or there, any of those 4 points, which would be at 0 degrees, 90 degrees, 180, 270, or even all the way around back to that original point that we started on, 360 degrees. Those are what are called quadrantal angles. And therefore, it must lie on the x or y axis and be a multiple of 90 degrees. The next type we'll talk about are coterminal angles. And coterminal, if you break that word down, co meaning same, terminal meaning ending. So if you literally break down the word coterminal, it tells you exactly what kind of an angle it is. It's an angle that has the same ending. So for example, let's make it easy. Let's say I wanted to go right here, and that was a 60-degree angle. Now, how could I get to that exact same point without going 60 degrees? Give me another angle measurement that would take me to that exact point. Well, it's very simple. If you had a little bit of time to think about it, we could always just add 360 degrees or even subtract 360 degrees to get back to that point. So coterminal angles, again, are any angle that has the exact same ending. So they must differ by a positive or negative 360 degrees. Okay, any multiple of that. All right, and we'll go over this a little bit more as we continue on, but just trying to give you all the basics real quick. Complementary and supplementary might be a little bit more familiar to you. Complementary and supplementary angles are when we are comparing 2 angles. And specifically, which is why we gave them their own names. Specifically, if I have a 90-degree angle, we call a right angle, and I was to cut it in any way, say like that, looks about right down the middle. Doesn't have to be, right? We can move that around and adjust it. But what I do know already is that this orange piece that I know makes up that 90 degrees, well, then these 2 angles together would have to add up to a total of what? Hopefully you said 90. Now, supplementary angles are very similar, but they're going to utilize that other angle measurement that we saw a lot, and that was that 180 degrees in the other 2. Okay, so those are the big numbers that break these things up. So those are the ones that we're going to be defining and taking a look at. So again, if I was to take any point along that straight angle now, and I was to cut it, then I know that this angle 1 and this angle 2 together would have to add up to that half circle, or 180 degrees. So the way that I often help my students memorize this is I simply use the first 2 letters and the fact that we're dealing with both 90 and 180 degree angles. So I know that C comes before S in the alphabet for my complementary and supplementary, and I know that 90 comes before 180. So the complementary is when the 2 angles add up to 90 degrees, and supplementary is when the 2 angles add up to 180 degrees. So that is the gist of angles and some of the attributes and terminology that we'll be using throughout. So try to memorize as much of this that you haven't already seen and learned before. Hopefully a lot of it was just a quick refresher. So remember those minutes and seconds that we talked about? Let's make sure that we can work with them because they will come up occasionally. Again, not too often, but I want to make sure that you guys can at least work with them. And I highly suggest that, just like you learned in early elementary school, you line up and stack them according to their position. And so when we did that with decimals, we made sure that everything was aligned with our like terms. Same thing with these. So we got 28 degrees and 35 minutes. We're going to add that to 63 degrees and 52 minutes. Now remember, I know our system is very funky. Like for example, how many inches are in a foot? 12. So if you're 6 feet, how big are you? Yeah, exactly, too slow, right? It's much easier to figure out how tall somebody is if it was by 10. So the history behind that is pretty lame, actually. We seceded from England, but unfortunately we didn't entirely. We still used the king's thumb, which happened to be 12 of his thumbs, up to his foot. And that's what we now use. 12 inches equals 1 foot. And then another king came along and he's outstretched from his chin to his outstretched arm in front of him. 3 of the king's feet measured up, and they called that 1 yard. So that's why 3 feet, 1 yard. The problem is they're all different, right? How many feet are in a mile? Most of you guys would have to Google that, right? I mean, it's just our system's not very good. So the one nice thing about this particular part of the math is that with the minutes and seconds, you already have that ingrained in your mind because you already know that 60 seconds makes up a minute. That still holds true here in trig. And 60 minutes typically makes up an hour. The only difference is because we're in trig and we're measuring angles, you need to know that 60 minutes makes up a degree instead of an hour. So with this, keep that in mind. Let's go ahead and rock and roll. 5 plus 2 always, no matter what, will equal 7. It's just a matter of what you're dealing with, right? So in this case, we still have 7 things, but that's fine. Now, when I add the 30 and the 50 together, that gives me 80, and that's not so good, okay? Because when you say a movie is 87 minutes long, how long is it? And don't say 87 minutes. What would it be in hours and minutes? And hopefully you said, well, I'd have to subtract 60 of those minutes and give it an extra hour. Now again, remember, we're just going to change that to a degree in this. And so that would actually leave me left over with an hour and 27 minutes. So we're going to carry that extra, in this case, hour or degree over to the 28 and the 63 when we add this all up. So now together, this gives me 9 plus 3 more would give me a 12. Don't forget to carry that one over as well. And then the 6 and the 2 together is 8 plus 1 more would give me 9. So we now have 92 degrees and 27 minutes as our final answer. So again, a little weird, a little different, but we've been doing things like this with inches, feet, yards. Those are the most common measurements. A lot of you guys wouldn't even know what to do with pints, cups, quarts, all that, gallons. So our system's pretty messed up. The metric system would be a whole lot nicer to use, but hey, this is what we have. So on part B, I wanted to see if you guys could combine what we did at the very beginning, example 1, and now this example 4. And I want you to find the supplement of that angle measurement. 50 degrees, 40 minutes, and 50 seconds. And if you remember from before, all we had to do was take what we know it adds up to entirely 180 degrees and subtract off the one we know in order to find the one we don't know, whose sum had to add up to that 180. Now, the problem with this is we obviously don't have any other seconds or minutes. We only have it in degrees right now. So what we're going to actually have to do with this is borrow 1 degree. Now remember, 1 degree was actually equal to 60 minutes. So the problem with that is we're still missing the seconds, right? I need to change it over here, and hopefully you remember that. Again, a little different, but I'm gonna have to borrow one of these. So now I have 59 minutes. And if I take one of those over, that was 60 seconds. So just think about this before we actually move on and do the subtraction. What did we know 60 seconds for our entire lives, pretty much, that 60 seconds was equal to? What was equal to 1 minute? And so if I added that back over to here, I'd have 60 minutes. And we knew 60 minutes was equal to 1 hour or 1 degree, which if I carried that back over to here, I'd have my 180. So we're just working backwards and dispersing it down. The biggest mistake that students typically make with this is they know they got to borrow from the 180 and they'll put 179, but then they'll put 60 here and 60 here like I have right here, and they won't borrow the 1 minute, which is 60 seconds here. So again, just be careful with this. I know it's new, it's different, but you'll get the hang of it. Now just do your subtraction like you always have with our base 10 system. So 60 minus 50, 10, you just need to know it represents seconds. 59 minus 40, 19 minutes. That's the symbol that we use. And then 179 minus 50 would leave us with 129 degrees. Okay? So not too bad, but it is going to take some getting used to and also recognizing what those symbols represent.